Hello everyone, so in this video let us talk about two important problems. The problem name is Fibonacci number and Tribonacci number. Now I think that most of you might know both of these terms, but it's still important to know these terms and revise it regularly. So let us talk about both of these problems in a very fast manner so that it will become more clear to you. The first problem is Fibonacci number. It says that a Fibonacci number, commonly denoted by f of n, as you can see here, is a sequence called the Fibonacci sequence, okay, such that each number is the sum of the two preceding ones, starting with 0 and 1. It simply said that you have a series, okay, a series of number such that the first number is 0. If I just draw it here, the first number is 0, the second number is 1, and moving forward after this, all the next number in this sequence will be the sum of the previous two numbers. So if I want to find out the next number, it will be the sum of both of these numbers, the previous two numbers. So if this is the number, the sum of the previous two numbers of this, it is 1 plus 0, that is 1. The next number will be the sum of the previous two numbers again. So the previous two numbers of this is these two. So 1 plus 1, that is 2. Similarly, the next one is 3, and so on. So this is how the series will go on. And what your overall target is that you have to find out f of n, the nth number in this series. Okay, so pretty much simple. What you just have to do is that you have to first, let's say the overall idea can be that you can make two variables, okay, a and b, and then use these two variables to calculate the next variable and then keep on shifting that. But because it's a series and the series maximum length can be up to 30, what you can also do is that you can make, let's say, an array of size 30 or maybe 35, whatever you can want. The first number in this particular block will be 0, next one will be 1. And for all the next numbers in this, let's say, array, what you can do is just use the previous two indexes and add them out to get the next index. And you can directly just fill out this array completely for maybe 30 numbers or whatever nth number you want. And whatever is the number you want to print out, that just print out. Okay, that is a pretty much logic you have to use for Fibonacci number. Okay, let us try to understand the code part now. So because n is up to 30, I have created a, let's say, a vector of long type. You can use long, whatever you want, which is f, and it is of size 40. Okay, just adding a little buffer. Okay, you can have made up to 35 also, whatever you want. Now the first f of 0 is equal to 0 and f of 1 equal to 1. So these are the two starting, let's say, numbers in the series, and you can just directly fill them out in the vector. Moving forward, you have to just do a for loop from 2 because you have already filled the value from 0 and 1. So you will start from 2 all to n. Okay, because you have to find it till n only. And then what you'll do is that f of I, the ith number in this series, is equal to the sum of the previous number. So you will access the previous number using the indexes. So I minus 1 and I minus 2. So f of I minus 1. So you have to use the numbers in the same array that you're building. Okay, this is the array. Let's say the array name is f. So you're just using for any ith value, you will get the value of f of I minus 1 and f of I minus 2. Okay, just add up both of them. So you will eventually just fill the complete array till the n you want, and just in the end just print out f of n, that is the nth number in this series, and you will just print out. Yeah, that's the logic for Fibonacci number. Similar to that, there is a Tribonacci number, that is the addition of the last three numbers. Okay, it's so if you just use the same analogy and the same, let's say, notation, the nth Fibonacci number will be just adding the last n digit. So it's the same thing, Tribonacci number and so on. So what you can see is that the first digit in, or let's say the first number in this sequence, because it's again a Fibonacci sequence, the first will be 0, as you can see here. The next one will be 1, the next will be 1 again, and then from t equal to 3, all these numbers from all of them will be the summation of the last three numbers. So the next sequence, or the next numbers or in the sequence, will be the summation of all of them, that is equal to 2. The next will be the summation of all the last three of this number, that is 2 plus 2, that is 4, and so on. Okay, that is how the complete sequence is built. And now you can use the same code that we have used for Fibonacci number here as well. So what we have done is that we have again created a vector of size 40. Initialize the first three numbers in the vector by 0, 1, 1 according to the given condition. And starting from the third, I equal to 3, or to till the n, you will first find out the answer of I equal to summation of I minus 1, I minus 2, and I minus 3. Just add all of them, and the end, just print out answer of n, that is the nth number in this sequence. So what you understood in both of these problems is that you have to use dynamic programming. What eventually I'm trying to do is that I'm using the previous information, whatever I've calculated before, to calculate the next values. That is eventually what dynamic programming is. Now coming down to the time complexity and space complexity for both of them, as you can see that we have created an answer vector of size 40. Okay, now you could have also created a vector depending upon the size, that is and how many sequence, let's say sequence numbers I want to find out. Then in that case, it will be O of n, but still the size is very small. Also, I have created it in a very static manner. I have only created it for 40. So it will not change depending on the program. So it is already O of 1 only now for our case. Okay, because I have statically defined it. The other case is that I have done a for loop only, just a one for loop over all the n numbers. So it will be O of n. Similar for Fibonacci and Tribonacci. So the overall time velocity in O of n, and if you just take the dynamic array as well, so O of n for the space complexity as well. That's the logic in the code part for this particular problem. If you still have any doubts, you can mention in the comment box of this particular video. I will see you in the next one, coding, and bye.